hydrolysis. And we expect pH to be greater than pK2. It's a basic species. We do I staple, right?
Professor, could you do 14 minus the pKa from the pKb?
Sure. pKb's, yes. So this one, sure. So KB1. Can we recognize it's KB1? Okay. K double divided by Ka2. Okay? Or, yes, like if you convert to P, right? You do subtraction where you used to have division for Ka's. Okay. Let me know if you have questions. We did so many of those. It's a weak electrolyte. It's not going to completion, just a little bit. Right? And so KB1 will be 10 to the negative 14 divided by 10 to the negative 10.329. So 10 to the negative what? You can just leave negative 14 plus 10.329 up here. I think I have more accurate value somewhere. 2.15 times 10 to the negative 4. Okay, all right. X squared divided by 0.1 minus x is 2.15 times 10 to the negative 4. Here I would be careful to assume anything. Look, my 0.1 10 to the negative 1 is kind of very, very close to KB1, right? Like, there is 3 orders of magnitude, but I wish it was more, okay? Maybe you can assume that x is smaller than that, but you are getting to the point that maybe it will not be a valid assumption, okay? If this value was much smaller than formal concentration, you can do that assumption, no problem. You can do assumption, but you need to say at the end if it was valid. Let me say what x was whenever we did the quadratic equation. Okay, it was 4.53 times 10 to the negative 3. So do you see, it would not be a good assumption, because we are only 2 orders of magnitude lighter here. So, okay, X is OH minus concentration, convert to POH. I'm out of space, I'll write here. POH was negative log of OH concentration. It was 2.344. And pH is 14, or pKw minus POH. I would say write it down, because if there is any mistake in math or whatever, the more you write down, the more points, partial credits you'll get, okay? Because if you just give me pH and it's completely off, I need to see where that came from, or, you know, and maybe you'll get 90-something% of credit, or maybe less, depending if I can see where your numbers came from. Yes?
How do you know your assumption's not valid?
You come at the end. and you say, if I assume that x is much less than this, is it true? And you're looking for difference at least 3 orders of magnitude, but you had here 2. 10 to the negative 1 and 10 to the negative 3. 2 orders, that's not good.
At
Okay.
least 3.
Yes. We are talking about 0.1% error or less. Okay. All right, good. And again, guys, if you are running out of time and you have a lot of stuff to do, I would say set up as much as possible. Say, I need to solve this quadratic equation, get x, x is OH concentration. After that, I would find POH, and 14 minus POH is OH. You'll get the most credit, a lot of partial credit, because, algebra takes time. But I'm not checking algebra, I'm checking analytical, okay? You need to do algebra, you have to understand it correctly, so you will not get 100%. But I hope you can do algebra. All right, here. All right. Systematic treatment. Okay, so we have silver phosphate that we are trying to dissolve, and it will not be very successful because Kp is small. But actually, it's better than what we expect because the product phosphate reacts with water. So do you see the first reaction will be shifted to the product side because concentration of your product phosphate will drop. We are removing phosphate from that system because it will react with water, forming hydrophosphate, dihydrophosphate, phosphoric acid. We remove the product, the equilibrium, first equilibrium will be shifted to the product side. So it looks like silver phosphate is not very soluble because Kp is so low, but it's actually better than what we think, because other 3 reactions will move the equilibrium to the product side. Good? All right. So, we have to come up with additional equations to solve unknowns. How many unknowns do we have in this system? Silver is one unknown. Phosphate is another. Hydrophosphate, hydroxide ions, dihydrophosphate, and phosphoric acid. So do you see we have 6 unknowns. If we say what Kp is, what Kb1, Kb2, Kb3, we only have 4 equations, but 6 unknowns. We need to come up with 2 more to solve for 6 unknowns. So I'm asking you to come up with a charge balance. Okay, so we are looking at all cations and putting them on one side. And guys, charge balance and mass balance equations is where you add concentrations. Constants, thermodynamic constants, equilibrium constants, is where you multiply concentrations. Okay, don't confuse yourself. Okay. So silver has +1 charge, coefficient is 1. We always can write water dissociation, but we know we will not have much H+, because 3 reactions give us OH-, and this equilibrium will be shifting to the left, or reactant side. So these 3 reactions will produce that. It's a product. We have a stress at equilibrium. The equilibrium will be shifted to the reactant side. We will not have much H+. If you want to write it and say, okay, maybe I need to take it into account, I'm not saying don't do it. I would say probably this system, H+ will be very long, but it's okay. Anything positive? No, that's it. We have phosphate, and because charge is 3 minus, coefficient will be 3. We have hydrophosphate, because charge is 2 minus, coefficient will be 2. And we also have dihydrophosphate, charge is -1, coefficient is 1. We also have hydroxide ions, that's good, so we need to add that. And we expect a lot of them. Okay. Charge is -1, coefficient is 1. Okay. This is the fifth equation that we would like to use if we have 6 unknowns. Mass balance is another one. Let's go and find mass balance equation for the system. That would be equation 6. Okay, that's good. How do we deal with mass balance? Mass balance is just another way to say that you cannot create species, you cannot destroy them, right? If you had phosphate, it can be in any form, but total phosphate will be whatever dissolved, right? So how to do it? You see that 3 reactions, second, third, fourth, they depend on the first one, right? They would not happen if silver phosphate was not in this, like, in the system. The first reaction is the main one we use to set up the mass balance. Let's set it up. So the mass balance says that silver's concentration will depend somehow on phosphate's concentration, and let's say total. Okay, how to make those two be equal? What do we need to do?
Multiply the PO4 by 3.
Okay, if we form magically 3 moles of silver, right? We also formed 1 mole of phosphate. First reaction, 3-to-1. In order for them to be equal, we need to multiply phosphate by 3, and then we would have 3 moles on each side. Good? Now we just need to look at all species present that have silver and that have phosphate. Silver is just by itself, so we will just say silver's concentration will be equal to 3, and we put parentheses, and we will say phosphate has phosphate, as well as hydrophosphate has phosphate, as well as dihydro, as well as phosphoric acid. Guys, why didn't I put silver phosphate there? It has phosphate?
This is solid.
Because it's not a part of the solution. It's a precipitate. Okay? It's not in the solution. That's why. Okay? All right, that's my 6th equation. But now here, I'm asking you to write all equations, and I'm giving you something else. I fixed the pH at specific value. How did I do it? I brought some kind of buffer that you don't know much about, right? You just know pH is fixed. Whenever pH is fixed, you know right away that H plus concentration will be 10 to the negative 8.50. And OH minus will be 10 to the negative, what? 14 minus 8.50, whatever it is, in that power. 5.50, right? 10 to the negative 5.50. You can provide those values in a different form. Something times 10 to the negative 8, or 9, and negative 5 or 6. Okay, but this is good. Look, at this point, by the way, I also, whenever I wrote this equation, h plus is kind of my unknown as well. Even if I know we will not have much of it still. Like I already, guys, know 2 unknowns. And because I got 2 unknowns, I can live with less number of equations than what I created. Whenever you have a buffer, external buffer that you add to the system, you need to know what exactly you added, in what concentrations. And if you don't, you cannot use your charge balance equation, because if it was a phosphate buffer, you know, you added more species to the solution and you don't know. And what was the buffer's concentration for each conjugate species? If it was some other buffer, what ions did we add? We don't know. But we are okay because we know 2 unknowns right away. Okay? Okay, so what do I ask you here, guys? I would like you to go over every reaction and say what constants are. So this is my first reaction. Second reaction will be KB1. So I would like you to set up your system of equations, but you would not need on the test to solve for unknowns. You did it, hopefully, for the homework. Guys, you would be surprised to see how many people make mistakes on this test. Okay, don't be those people.
Be better.
Okay, you already, or I already use KW equals to H plus times OH minus to go from H plus to OH minus concentration. So 4, and my mass balance is the faith. So I would just say silver equals to 3 times phosphate times hydrophosphate plus dihydrophosphate plus phosphoric acid. You can say that charge balance is not valid. And you can say something about buffer or just say that. This is good. Okay? So keep in mind, for charge balance and mass balance, you add concentrations. For all these equilibria constants, you multiply concentrations. Don't forget about coefficients, stoichiometric coefficients. They will be power. Okay?
Why is it the charge balance isn't valid again?
Because you added some charges to your system and you don't know what they were.
Oh.
What buffer was added? Okay, so you don't know what other charges were added.
But if we know the buffer, we put it down.
Hmm?
If we know the buffer and what we've added, then it would be able to be put down as one of our equations.
Like, because the buffer was added, you know these 2 values right away. So you are down in number of unknowns. You can sacrifice 1 equation or 2.
mean, at that point, like, do we really care what the buffer was?
No.
We can just use it to find the rest of the.
Exactly. If I say 0.1 molar hydrophosphate was added with or 8 molar dihydrophosphate or whatever, you could use it for charge balance equation, but there is no need.
Because it says it's fixed.
Yes,
at 8.5.
because you do not have as many unknowns at this point as you had before. But I want to see that you can write charge balance, you can write mass balance, you can set up the system of 20 equations. I'm generous to say don't solve at the test, but I need to see all of it,
Let's say if this was a solved question on the test, it would take half the test time.
or more,
That's it.
depending on how many equations you have to solve simultaneously. Good? You're good?
Yeah.
All right.